This video will discuss Chapter 8.4, Rate of Change. So we're going to talk about the formula for the rate of change, which is the change of y over the change of x. And I want to start with this first graph, which is talking about the vertical position of an airplane related to its horizontal position. So going up as opposed to going across. And so I want to look at this difference between point B and point C. And so if you look on the graph at the coordinates of point B and the coordinates of point C, you're going to create something that looks something like this. Okay, and so this is point C. This is the x value. This is the y value. And then this is point B, x value, y value. And when we simplify this, this becomes 400 over 400, which can be simplified to 1. So for every 1 foot it goes up, it also goes 1 foot across. Another example might be in talking about salary. And so we're looking at hours worked compared to money that is earned. And so this becomes, I'm going to subtract this point from the first one. So this is going to be 85.50 minus 76, and I'll put the 0.00, over 9 minus 8. And so this becomes, let me make sure I'm doing the math right, 950 over 1, which means that this person is earning $9.50 per hour. So for every hour they work, they make another $9.50, and that's the difference there to there. Let's take a look at an example. Here this would be an example of when it's negative. This is of a roller coaster. So as the seconds increase, the height of the roller coaster actually decreases. So you think about the roller coaster, it's in one of those big drops. And so I can take any points I want. So I'm going to intentionally pick these two. And so this is going to be 80 minus 456 over 2 minus 0. So these two are married and these two are married. So it's really important that you keep those together. And so 80 minus 456 is negative 376 over positive 2. And so when I divide this by 2, I end up with negative 188 over 1, which means that it is dropping 188 feet per second, which makes sense if you think about a roller coaster. It should be negative. It starts up high and then it drops down. Okay, and then the final example, and I'll show you the problem in the book, and then we can talk about how this would look mathematically. But I'm looking at this. Let me pick this up. Hold on. Looking at this problem here, where we're talking about revolutions of a record on the inside track and the outside track. And so I'm purposely going to pick 0 seconds and 2 seconds for both of them, but we're trying to compare which is faster or which has more revolutions, the inside or the outside. And so you can see that I set it up like this. And so the inside track is 16 minus 0 over 2 minus 0, which this becomes 16 over 2, which simplifies to 8 revolutions. And then over here, this becomes 6 over 2, which is going to simplify to 3. So as you can see, the inside of a CD, and this would make sense if you think of this as CD, it's going to have more revolutions on this inside than it would going around the outside. All right, that's all I got for you on rate of change. Don't forget to do the problems on the bottom of the page. Thanks for watching the video, and I'll see you in class.